Everyone. My name is Vaibhav, and before we go too in deep into it, I just want to ask people a couple of questions really fast. How many of you use LLMs today in your products or your teams that you work today on? A couple of you. How many of you use them to generate code as a part of that workflow? Hopefully a lot more hands. How many of you would trust an LLM with your life? One of you. How many of you would trust an LLM to process your visa application? Any of you? Like, what if we lived in a world where we could? What if a lot of the stuff that we typically can't trust models on, suddenly we could trust them on? What if we could feel confident that when a model produced something, it was reliable, it was trustworthy, and it actually didn't make stuff up? What if, and like some of the stuff I'm showing you might be totally recorded, so like let's just try a real thing. This definitely can't be recorded. What if when you're doing this and you ask a model to go do something, it was able to understand your system really, really well, and you could make it work? I think that's what I want to talk about today. How do you go from not having trust in models to trusting them? Does that sound interesting? Yeah. Cool. Let's go talk about that. So before I go into this, how many of you have written an agent loop before? A couple of you. How many of you know what the word agent means? Can I take one hand and who wants to shout out what they think it means? What's your name? And say what do you think it means?
Tom, I'm an LLM that uses tools.
An agent is an LLM that uses tools. I think that's the definition that a lot of people may say. One more hand. What's your name? And say. Saha? Okay, that's another definition. A thing that has some autonomy and has decisions to make some tools and reasoning. I'm going to share a different definition that I think will at least has helped me come to terms with what I think an agent is. And just to give you a little bit of context on how I approach stuff is, I'm a software engineer. I really like code. I really like type systems. I really like autocomplete. I like a lot of the basic stuff, nothing fancy, and I'm good with it. I love AI to write code too. It's just really good autocomplete. But I think the premise that I usually like and hold is whenever we come up with new systems that come out there, I try and use old definitions whenever possible to try and explain them. Because if I can do that and not invent a new term, it's easier for me, personally. So I'll show you the way that I have been thinking about this. Oops. Notion will open. And let me know if this stuff is too small or needs to be zoomed in before. So let's talk about some agentic stuff. And as we talk about this, I'm going to describe how I think of an LLM first, and then we'll talk about how this applies to context engineering and everything else we might want to go do with it. So what is an LLM call? Well, I'm going to redefine an LLM call to be something really, really easy, which is it's a type system conversion where you're going to go and give it some parameters, and you're going to expect some type system to come out of it. In this case, in the case of classification, I'm going to give it a string, and I'm going to expect it to give me one of three literals. That's one way to view a call. And the fact that I happen to use an LLM to do this transformation is an implementation detail, so we can just ignore that. But assume an LLM can do this reliably, and now I can use a type system to go do this, and now it's just a function call with a specific type signature. Now, it may fail with some probability, because LLMs don't always listen to us, but so do APIs. APIs go down all the time, and we know how to deal with that. We just deal with exception handling and everything else there. But as long as we view it with this function signature, it's a little bit more familiar. So in this case, how do we use it? Well, we just call a function. It's really nice. There's no new concepts, so let's go with this a little bit further. What about tool calling? How do you think about tool calling? Well, the way I have thought about tool calling is another type system conversion. I'm going to give it some stuff, which is a type of any kind. It can be a string, it can be a string array, messages for a chat history, or anything I want. And I'm going to return a union of types. And what I do with this union of types is these are all data models that are described the parameters that I might want to pass on to some other function. But they're described as a union of types. So again, the fact that I'm using an LLM to do this conversion doesn't really matter. The fact that an LLM does tool calling doesn't really matter. Fundamentally, I'm taking in an input and describing it back as a union of types. So now, how do I go use this? Well, what we do is we call the function, and then we just use a union of types to decide what we do. And I think most people know how to handle unions of types. You call if statements, and then decide what you do, and then you can branch accordingly. You can use discriminated unions or something else as well. And then the fact that we can call a method or do a tool call is really just calling a function with some parameters. So let's not invent new words there either. Let's just try and use words that we're all familiar with. OK, well, what about multiple tools? We've heard parallel tool calling to make your agents faster. Well, this definition gets, I think, even easier to think about. Instead of a union of types, it's an array of union of types. That's what parallel tool calls are. I want to run multiple things in parallel, and I can think of it in this way. Well, my calling code also becomes really simple in that case. Now I just change this to a for loop instead of a single if statement, and I can suddenly run stuff in parallel. If I actually want to execute in parallel, I use an async for loop, where I run all the stuff in parallel, and now I can go resolve that. Everyone with me so far? Any questions? This is going to be a fun conversation. As you guys have questions, just raise your hand, and we'll go take them, say your name, and ask the question. I think it makes these kinds of conversations way more interesting. OK, so we've done LLMs. We've done tool calling. We've done parallel tool calling. What about agent? What the heck is an agent? Anyone want to posture a new guess, given what I've shown so far? Any hands? OK, I'll show it. I think an agent is really just a while loop with some state. And what does this mean? If you've ever written a tic-tac-toe game when you first learned how to code, most of us have probably written something akin to that. Well, that is almost an agent of some sort. You have some state that represents a game board. You run it infinitely until there's some terminal condition. And then you decide to go either end the game and display the result, or start a new game and re-begin that loop. I think we can view an agent in that same paradigm as well. It's a thing that has some state that represents the actions that what has happened in the world to this date. And then you have some way to transform the state into the next transition. So what do we mean by this? Let's look at some tangible code. So in this case, I have a chat agent. My state is represented by an array of messages. My messages are just, in this case, I've named it role content specifically because it aligns to the API, but it doesn't have to. It can be any state I want. And then I'm going to return a variety of tool calls over here, which is get weather, add reminder, and reply to the user. Well, what does it look like when I actually go write this code? Well, I can write my agent. I have some initial condition that starts the agent. So that might be the first message my chatbot gets. And I just run a while true loop. In this while true loop, I get the action given the current state of the world. I make my discriminator based on the union of types that I have. And I might call another API in there. And I just modify the state once again. I add more data into my state, and then I go back and start the while loop again. Similarly with add reminder, I add more data to my state and go back again. Notice I don't actually have to take the exact raw responses of every tool call or every function call and put it directly into the state verbatim. You might want to apply some transformations to make the state more semantically meaningful based on the job that you're doing. And at some point, I have a terminal condition along the way as well, where I will exit out of this while loop, or maybe I won't because I'm down to run this thing forever, and actually show the final state of the world to the user. Along this way, I could have made many different decisions on how and when I would stop. I could be stopping because it's been too long. I could be stopping because it's cost too much money. And I could have stopped because it reached a terminal state. All of these are concepts in the agentic world that I think make sense. But if you just think of it as a while loop with plus state, I bet most people could write this code and make it work if you just take out agents out of the vocabulary. This stuff, I think, shouldn't be too hard because most people have written while loops. So if we go on with this definition of agents, we have a new term that I think I heard a few times, subagent or handoff. How would we think about that? The way I've been thinking about it is I think that's like a no-op terminology. Like it's not very useful to think about because technically the line that I called get weather could be calling another LLM inside of it. And if that has a while loop and state in there as well, I guess we have a subagent. But what it does doesn't really matter. This is just a while loop plus state. And a handoff or a subagent is just a function call that does something else. And as long as we can debug it with all our existing tooling, I think we can get a lot further in developing software. And I think this is the premise of what I want to discuss today. When we think about context engineering, when we think about making our agents really reliable, how do we take all the things we've learned in the last 30, I guess 50 years of software engineering and apply it without having to rediscover everything from scratch? There's a lot of learnings from distributed compute that we've learned about how to get like 5 nines of reliability. How do you get 1 9 of reliability? There's a lot of learnings we learned through exception handling. There's a lot of learnings we've had about how do you share code how do you share APIs that are flaky and go down all the time? How do you build SQS queues that are reliable? And if we suddenly invent a lot of new terminology, we almost have to rediscover all those concepts again. So I'm not saying we should not invent new terminology. I think new terminology can be really useful for shortcutting certain definitions. But what I find is minimizing when we add new terminology helps a lot in communicating and accelerating shipping of reliable systems along the way. So that's my quick primer on agents, and we'll get to context engineering really fast. So this whole premise of what we do is kind of the thesis that we had when we started working on some stuff. And the idea is that we took this thing to the nth degree, like any engineer would when we're really bored, and we made a new programming language. Why? I really don't have a good answer, but I think the simplest answer that I would say is I really like type systems. I really like beautiful code. I think code is almost artistic in some sense. And the minute you take away the beauty of code, I think it starts to turn into a mess, and then we start wondering why this code existed or who wrote this code in the first place. So we said, all this agentic code I've ever seen is really, really ugly. Let's see if we can make it pretty, and along the way, maybe the prettiness can help us understand the world a little bit better. I'll give you a really quick analogy. How many of you would use a website that does this? 5% downtime. Anyone? But I'm going to change one word, and I wonder if you have a different opinion. Anyone feel differently? I know a lot of people might. And I think this is not OK. Like, we should not accept that. We, as software engineers, would never use a product that worked 95% of the time. Your customers will never use a product that will work 95% of the time. And if you've ever seen any of the talks that people talk about, they talk about reliability and everything else. But the reason most GenAI applications fail is because of this transition. Most of the time, people have never thought about dealing with the burden of a distributed, of probabilistic systems and where they can fail. And I think one core reason is there's this really nice company back in the neighborhood of where I work at in Seattle. They have like a product that has 3 letters, I think AWS, that has a lot of engineers that work on making it so this 5% of the time is not a thing that you as a company have to deal with. But now when we build application code, suddenly the minute you add LLMs, it is a thing you have to deal with. And there's nothing AWS can do to make your life better. So how do we approach this world? How do we apply techniques to make it so that your code can be better, more reliable, and not have 5% failure rates? So who am I? My name is Vaibhav. I've spent my whole career basically working on really, really weird probabilistic systems. For example, I worked on the first AR headset that the world had, the HoloLens. I worked on building parts of Face ID and augmented reality technology over at Google, where if you want to take that window, for example, or a doorway, how does an AR system detect a doorway? A doorway is an absence of space, especially if it's open. A window that's actually clean should be invisible to a camera. A mirror is a reflection of the space behind you. How do you detect that it's a mirror? These are really hard problems. There's no way to really build ground truth around them. And at some point, I ended up joining DE-Shaw and actually going through the foray of actually like thinking about how Python works and optimizing weird parts of Python under the hood. And then my co-founder did the other side of probabilistic systems, where he worked on Core EC2 and Prime Video to actually build distributed syncing across the watch parties, where you can actually go ahead and sync state if you and your partner are watching videos from across other sides of the coast in America. So at some point when this AI stuff was happening, we said we probably want something that solves that problem in the way where things are just going to fail in application code all the time. And we probably don't want to have 5 layers of nested try-catches in our code base everywhere. We probably don't want infinite LLM retries just to get correct JSON. We probably don't want code that should be deleted in 6 months because it doesn't meet the coding standard of any other system that you would check in. And you want something maintainable. And I think the closest analogy is websites. Some of you have probably written a website like this at some point. Hopefully, none of you are doing this anymore and are writing websites like this. For those of you that aren't web developers, this is React. It is amazing, and it's much better than this. And there's 3 main reasons why I personally find it better. One is pretty colors. I think colors are nice. Colors just help me see things much faster. And there's a reason, for example, why code is syntax highlighted and why we use dark mode. It's because your brain actually doesn't even read the full code. It just skims over the colors and is able to use context clues to quickly understand it. On the other hand, there's another thing, which is really, really, really good errors. If you forget the slash here, it's a compile time error. That means you can't ship code. Your release pipeline will be blocked if you made that mistake. If you forget a slash here, you now have a really weird website. And I know browsers have now made some error corrections to go fix for this error, but there's definitely some set of errors they cannot fix under the hood. And I think the last part is it allows you to think in a totally different way. This way of saying that all the state is componentized, and you don't have to go think about it. The fact that use state means that you as a developer don't have to think about re-rendering this component. You just call set count, and it magically re-renders and shows the right thing to the user. Means that when I was graduating from college in 2015, I remember a very, very hard problem used to be build an infinitely scrolling website. And the reason that was hard is because you have to do it in jQuery. That is so hard to manage. You got to build all the templates and stitch all the strings together. Now with React, there are freshmen in college that build better websites than I ever could, even with AI. It's because the syntax that we use can fundamentally change the way that we think about problems. And if you think about data pipelines, it's very similar too. You probably have written a data pipeline like this in a Python file, but I bet you most data scientists don't use .py files. They use IPYNB files. Why do they do that? It's because the iteration loop is fundamentally different. You need something that allows you to see something, see if it works. See something, see if it works. And if you go back and think about how agents look, have some of you written code that looks like this along the way? Perhaps have some code that looks like this even further? How many of you look at this code and go like, yes, I am proud of this system? Anyone? OK. I mean, I'm not going to judge, but I get it. And I think the reason is we just want this stuff to work. So I'll show you a different way of thinking about this whole thing. Sorry, Zoom levels are hard. And I think it's that these systems have a very, very similar problem to what HTML had when you were first writing code. It's a very similar problem to how Python has compared to Python notebooks. You have a bunch of strings, and as we saw, strings are bad. No pretty colors, no syntax highlighting, no error checking that you have. Whenever you break one thing, you have no idea what downstream impacts you have. If you go back to this code and you suddenly change the budget estimate, I hope you change your type system somewhere else. Or if you change your type system, I hope you change this. And it's really hard to bring a stitch together. If you have a new model, you now have to go figure out how you integrate that API across your code base. How do you enforce that people in your company are using the right model? You can't, because they can just write client.chat.completion create, and there's no static analysis or linting you can do on these systems. There's no way to even tell a new engineer on your team what the right premise is. And in the world where we have AI generating more code reviews can't even check this either, because you can't really code review AI generated code. And if you can today, because you have processes, tomorrow, when AI generates 10,000 lines of code per second, you definitely can't code review that. It will be written faster than you can read. So you need systems in place that can help catch these errors rather than hope and processes that are much slower than the generation time. And I think when we think about this, I'll show something interesting, and then we'll go into context engineering right away, because I think this will help us do some interesting techniques with context engineering around the way. So what does an alternative look like? And I apologize. Some of you will hate me, but I hope you will forgive me. I will use light mode. Hopefully, it's a little bit more clear what's happening, and it's a little bit more readable along the way. So I'm going to describe a different way to go back to that original thing we talked about. LLMs are just function calls. Tool calls are just while loops plus state. And I'm going to write some of this stuff and show you some really interesting ways where if you model your agents in this manner, your prompts will get better, your accuracy will go up, and your reliability will go up, and your latency will go down, and hopefully your cost will go down as well. So OpenAI, let's use GPT-4o Mini. The first thing I did is I wrote this as a function. I have a thing that's called extract resume. It's going to output a resume type. And my resume type is described in code rather than in any other system. So it looks like code. And sometimes my code might have some English in it. But there we go. Sometimes my code might have some English in it, but it's mostly code in type systems. But unlike most other systems, I'm going to write my description of how this should execute with a model. So this is going to execute using OpenAI GPT-4o Mini, and it's going to use this prompt along the way. Then I think the most important part is you're going to write some test cases. If you're not writing test cases, your AI pipelines probably aren't working. That's probably why. Write some test cases. No matter what you do, write at least one test case per LLM call. If not more, but at least one. And then what we'll do is we'll actually just read the prompt. And I think this is the biggest mistake that a lot of people make. They don't actually read the prompt. I've met so many folks that have AI pipelines, and the prompt just gets incrementally added. And usually like Cursor or Claude or Codex or something else is writing the prompts. So not only have you never typed it out yourself, you've actually never read the final thing. And as you increment and address every edge case that comes up, you never definitely read if there's contradictions or not. And I think the most common mistake that people make is because they don't read the prompt, your prompt naturally ends up contradicting itself in really subtle ways that you don't expect. And at least for me, I can't remember all the code I wrote 6 months ago. I definitely can't remember the prompts I wrote 6 months ago. So I find it incredibly useful to every time I change a prompt, just read it. But once you can actually read the prompt, you want another thing. You definitely want to know what the web request being made under the hood is, so you should be able to see that. So in this case, we can see exactly what it gets easier in dark mode. Theme, dark. Can you guys see this? Oh, I'm going to go back to dark mode. It hurts my eyes otherwise. You can actually see the actual curl request really, really easily. And you should be able to do that. Because any system that's making a request, if it's modifying the prompt in any meaningful way. So for example, we have a lot of companies in Japan that use us. Why Japan? A couple of them just found us, and it kind of just worked. But part of the reason they really liked is because if you use any framework and adds a little bit of English into your prompt, suddenly your really meticulously crafted Japanese prompt is going to start outputting English in a way that you don't really understand why, and then you quickly realize why. It's because the system added some English into it. So it's really important that you can see the full message before you go into it. But I think the most useful part is you should be able to hit play and see what your prompts do really fast. So in this case, it was able to actually run and show that I had extracted my resume and did some stuff. Let's make this a little bit more useful. So let's add some reasoning. How many of you have used reasoning in models before? How many of you have used in-context reasoning, where you actually have the model do reasoning as a part of its context instead of using a reasoning model? A couple of you. So the technique was, I think, originally defined as like chain of thought. Let's try and do something like that. Before you answer, list 3 reasons why this person is awesome. I am pretty awesome. Example. And I'll just read out the prompt, and you're noticing schema. Sure. And you can just read the prompt. There's nothing tricky here, no fancy voodoo science. I'm just telling the model to go do this as a part of my prompt-based instructions. Well, let's see what the model does. Well, the model should, in theory, do that. It outputted reasoning, and then it spit out the thing I want. And what I got out was just the thing I wanted, because that's what the function signature said. The function signature says, no matter what happens, give me a resume type out of this system. So the model outputted a string, and we got the resume type out. Let's take this a little bit further. Why are we using quotation marks? I think the only reason we're using quotation marks is because JSON? But like, does the model care about JSON? Probably not. Is JSON even the best way to represent all things? Probably not, because we don't use JSON everywhere clearly in the world. We use it in a lot of places, but it's probably not the best. So let's just see if we can do some stuff. No quotes around keys. This is what the prompt says, just no quotes around keys. When I go run this, the model outputted some stuff. It didn't put quotation marks anywhere. So this is no longer valid in most senses, but still works. Because you shouldn't have to rely on the model being perfect. A model is a thing that is beautifully imperfect. That's what I loved about working with models in my past. It's because they can make these mistakes, and sometimes the mistakes are actually good. But what I love about software and algorithms is that they are perfect. And while they're not as flexible, they're really, really rigid in what they do. And I think the marriage of the two is what actually most software works as. So like most people think about Face ID. Most people probably assume Face ID is a single model on their phone that runs. It's actually not. It's actually a combination of multiple models combined with algorithms. And why do they do that? Well, it's a lot more accurate to combine the two together. Heuristics are still really powerful, but not as powerful if you run them alone. And models are really powerful, but not as powerful if you run them alone. So the whole point is, instead of everyone having to write their own heuristic, how do you invent a heuristic that everyone uses? Well, we have a concept for that. In most software, it's compilers. If any of you have written some code, and the code is magically faster than the code you probably wrote, the compiler does that for you. You don't think about it. So in this world, because you gave us your type system, what we're able to do is say, no matter what the LLM spits out, we can give you the thing that you want. And we do this in under 2 milliseconds, with it all locally without any additional LLM calls. So it's actually free to run, assuming you have an AWS or some other cloud provider micro instance, or a machine that is at least as old as like 1960 or 1990s, and has enough memory to go run everything. But it does run really fast. But now we can actually model LLMs as systems like this. We can do techniques like in-context learning, or in-context reasoning. And it's not to say that you shouldn't use a reasoning model. Reasoning models are still powerful, and you should consider them. But you shouldn't be forced to use a reasoning model. You should have the flexibility of doing what you want along the way instead of doing this. And you shouldn't be forced to render JSON. And I want to talk about that a little bit more in detail. Sorry, I'm going to find the Notion page that I want to talk about. I apologize it's not slides, it's all Notion, because I really like coding, and making slides is a lot more annoying than writing a couple Notion docs. This loads. OK. So like, why is JSON bad? Well, let's think about that for a second. Well, that technique I showed you is called schema-aligned parsing. And the idea is that the model can give you something approximately close to what you want, and we can extract the correct schema out of it. The nice thing about schema-aligned parsing is it actually ends up being better on every model across the board. And there's a blog post I can go share about it where we run tool calling benchmarks. And I'll give you an intuition about why it's better. Because not only does it end up being cheaper and faster, it ends up being more accurate. So like GPT-5 came out more recently. Schema-aligned parsing with GPT-5 is better than GPT-5 plus tool calling. And I'll show you why. Let's just take this example of me wanting to generate code. If I want the model to generate code, and I go run in this way, how many of you could write code like this if you tried really, really, really hard? How many of you can go on a whiteboard and write code that compiles perfectly? Probably very few. Writing code without syntax headers and all modern tooling just makes life harder. On the other hand, how many of you could write code like this? Probably a lot more. And in general, the quality of code that you generate when you defy away from JSON is going to be better than the code you get from JSON. So what you want is you want some structure to the system, because you still need schemas and everything along the way, because the rest of our world still uses schemas regardless of how much unstructured data is. You still want data models and type systems along the way to merge with the rest of your code. But you definitely don't want to be forced into using a serialization format that is great for humans to go read, or like parsers to go read, and you want something a little bit more flexible. And this actually improves the quality of the system quite a lot. If you go further, let's take a different example. And I think this example really is what helped me think about it. We just talked about reasoning a little bit ago. Another way to do this is we had someone want to do transcript diarization. Oops, let me just save this image. Download. We had someone do transcript diarization. And like, what is transcript diarization? The idea is you can take a transcript and align who the speaker is on the transcript for every message that comes in. And they're in the hospital setting, so they have to deal with like patient-doctor conversations. But if you've ever been in a real hospital, it's very rare that only 2 people are talking. You have a lot of other people in the room often as well. They might be partners, they might be nurses, they might be other doctors. How do you do all this identification really trivially? Because all you have is a transcript and an audio file. Well, one way is we can actually tell the models to do some in-context reasoning. And the way we'll do this is we'll tell the model, in case the speaker is ambiguous, I want you to list out relevant facts to narrow down the speaker. And I showed a pattern of how to list out random facts. and then tell me who the speaker is. So for example, if they use first-person pronouns and had an accident, it's probably a patient, regardless of what it is. If they use second-person pronouns and had an accident, it's probably someone related to the patient in some manner or form. And you can make that inference. And then we'll run this by the model. And when the model generates itself, for at least a couple transcripts, it's going to generate some stuff like this. We'll say speaker, doctor, and it'll tell you that this person is a patient of why it expresses the patient. And then down here, it'll say the same thing. And it says how it's making that inference along the way. And then it says speaking about the patient in third person is probably the other. So the model is using in-context token generation to help it actually produce way more accurate data. But if you had to force it to generate JSON, it wouldn't be able to do this. You'd have to inject some new fields as a part of your system to say, here's a reasoning. And then the model will have to do this for every element along the way. And while I'm not saying that you shouldn't do that, I'm just saying that shouldn't be your only option. And when you're building with AI pipelines, you want to have as many options as possible to build the best pipeline you need to, because you don't know what technique will apply to what world. And when you get this and you can have a parse that is really flexible, all you get is your type system out, and you don't have to think about it. You're guaranteed for this to work. I'll pause really fast. Thoughts so far? Interesting? Keep going? All right, we'll keep going. So at some point, you're probably like, OK, this thing is mildly not totally silly, and maybe it has some interesting parts to it. But what I really want to do, I apologize, let me find the right window. What I really want to do is I want to write some Python code. Or maybe I want to write some TypeScript code. Or maybe I want to write some C# code. Or some Go code. Or some other system, because that is the language I choose to write. And I think one of the most annoying parts about agents to this date that I have seen is everyone tells you, go write Python. I hate Python. And it's not I have anything against Python. It's just that I spent my whole career writing assembly code. I spent my whole career writing high-performance optimized systems. I want to write that kind of code, and I want to be able to use LLMs in that pipeline. I think SQL or SQLite should be able to support an LLM pipeline inside of itself natively. That code is all C. I think there's a lot of companies that have built off of Ruby. Those companies should be able to use AI pipelines without having to spin up a Python microservice. Because if I went to a system design interview, and let's imagine we're not talking about LLMs, we're just talking about some random web API I want to call, and the person draws on the board, and let's say I go on the board and I say, hey, I know we have a Go backend that we spend a lot of time working on, but I want to I want to turn this thing into a Python microservice so we can call this website. That thing wouldn't pass. Like, you would just say, why didn't you just do it in Go? I think when it comes to LLMs, oftentimes the real thing that's lacking is tooling. So I'll show you how we approach the world in this way that I think actually helps, again, with this context problem. Because context engineering is purely about, demo.py. Context engineering is purely about having this information available to everyone in your group. Because if they're able to build really good context and really good prompts and really good pipelines, your system will just have increased accuracy along the way, and you're closer to not having that 5% failure rate. So let's just take Python, for example. How does this work? We have a function called extract resume. Bama client, import B. And you're noticing it should be auto-completing along the way as I type this in. So I'll pass in some resume into here. And then resume should have a bunch of fields that I have. Resume.experience should be a list of strings. Why? Because resume.experience is a string. I'm going to change this to be an experience array because I want my data model to be better. I'm going to run the test really fast just to make sure it actually works. And the model is able to understand what I wanted. Cool. It seems to have understood what I wanted. And I suspect I would want this to be updated, and it is. So my type system is fully reflected across every language. As I change my type system here, if I go back to string, this becomes a list of strings. Any of you use streaming in your applications? How many of you aspirationally want more streaming in your applications? Hopefully all of you, because if you're not doing streaming, I'll show you one thing that you can't build. So we all know ChatGPT can generate recipes. But what I really want, why do I want streaming? Well, it's because time to first visual is really important. And I view that differently in time to first token. But it's really important that people can see what's happening. You don't want a black box to run for 5 minutes. I will literally go back. If my website takes too long to load, I will leave the website. There's a bounce rate associated with how fast your website is. And the same is true with agentic pipelines too. So we all know ChatGPT can generate recipes. But like, what if I can interact with the recipe while it's being generated? Like, this should be possible. This should, in fact, be really easy, hopefully. And if it's not, it's because our systems require a lot of code to make this work. It's the same reason why React makes making that infinite scrolling newsfeed trivial, and why doing it in jQuery and HTML is incredibly hard. It just doesn't have the right tooling and the right level of expression of idea to make this possible. So how do we make this possible? Well, key tip, type systems. Type systems are really, really nice. So let's do a stream. So when I'm streaming my name variable, my name is optional along the way. But when I'm streaming the resume and I'm streaming the name variable, it's completely optional. When I'm done, name is done. You have a complete type safety model where you have a different type system that exists during streaming. Let's say I actually want the name to be done while I'm streaming. Well, I can tell it that. I can just say that even while streaming, I want the name to be actually done. Or in fact, it's not about it being done. I'm not even going to allow a null type while it's existing. Well, now my type system will tell me that. Name is not allowed to be incomplete. Name must be done when it comes in. So you can actually control the type system really well. What does that mean from a visual standpoint? So I'm going to run this experience thing again, just so you guys can see. And pay close attention to how it visualizes when it streams in. Do you notice how this experience is streaming in along the way? What if I want the array to come in completely when it's done? Let's just tell it that. It's going to visualize differently, even though the LLM fundamentally hasn't changed anything at all. And now you only got the array as it came in. Similarly, but what if I want the array to stream, but I don't want every element to stream? Well, we can just say that. We can just say that I want the array to stream, but every individual element should not stream. And I think we're going to live in a new world where, and you see how that comes in. So now you can use your type system to express the desire of what you're trying to do. And what that means is building a really interactive UI here is really trivial. You have a way to render a recipe. And based on the recipe, you have a use state that is triggered based on use servings. Servings is a thing that is generated by the LLM. And then I just multiply some numbers together and make that happen. That's all React. There's nothing fancy there. I just re-render the component based on every valid data type I get in, and I know how to render that. This is the thing most people can build. You can take away the burden of what people have to think about if you can make type systems do a lot of the expression of ideas for you. But I think, like I said, we don't want to live in a Python world. We kind of want to live in a software world. All software should be able to do this, not just Python. So that's kind of the idea of BAML. When you write code in BAML, you kind of get the ability to use it in every language that you want. Python, TypeScript, Ruby, Java, C++. You name the language, Haskell. You name the language, it works. And what that means is your type system works. When you're going ahead and running resume.experience, this thing is a list of experiences. Let's change this back to a string. This thing should, in theory, TypeScript is slightly slow on the reload side. But this thing yells at me now, because company doesn't exist on this type. So now if someone is prompt engineering, your system will break when the type system breaks. So if someone changed the prompt for whatever reason, you get a compile time failure, not a runtime failure. This means your app is suddenly way more reliable, because you can't release it anymore unless it works. Some of you are probably wondering how this works. I'll give a quick 2-minute spiel, but then I'll go back into more context engineering tips. And time check, OK. How this works under the hood is in Python, what we do is all this BAML code actually generates underlying Pydantic systems. And then we do the type conversion automatically for you, so it feels native in Python. In TypeScript, we do the same thing. Everything generates interfaces that are very easy to generate. When you talk about streaming, we actually generate different interfaces for streaming versus not streaming. And the reason that we do that is because we want really good type safety when people can control the level of streaming that they want. What field stream, what type stream, all that should be easy to get. So if I change this to experience, and the file reloader is slow, this changes to experience in TypeScript. If I change it to experience, let me show you the streaming version. If I change it to, if I change this to a stream dot not done, the streaming type changes to the original experience type, not the streaming variant of experience. So it actually gives you great type safety along the way, and this is why we do this with CodeGen. Under the hood, all of this is backed by a common Rust core. So you actually have the same bugs. in both places. So the lack of bugs and the presence of bugs is universal. It's not just for Python, it's not just for TypeScript. It's actually going to give you the same experience anywhere. It has the same performance. And it should, in theory, make your app a lot faster because we have a much faster networking system than core Python or TypeScript does. Not faster than Rust, sadly, because we have some overhead. But if we apply this way of thinking a little bit further, I want to go back to more context engineering along the way. So now we have this pipeline. It can use GPT-4o Mini. It can extract some keys and resumes. But I really, really don't want Gmail emails. So maybe I'll just prompt the model. I'll tell the model to do something like this. Add description, ignore Gmail emails. And I can write this into my prompt, and this will work. So I add a few more tokens to my description, and now it goes into the prompt as part of the prompt system. And then I run the system, and then in theory, my test case should tell me that it didn't work. And what the model, oh, I ran the wrong test case. Sorry about that. Run this again. In this case, the model spit out a null for my test case, and I got it. It actually listened to me. That's great. But I probably can't guarantee it would listen to me. I probably want some guarantees of some kind at some point for some code I'm writing. Well, let's add a guarantee really fast. Instead of using the prompt to generate this, I'll actually just add a type system declaration on the type. I'll say, this thing is a string, which is not allowed to have gmail.com in it. And when I run this, what will happen is the model will generate some stuff, but the thing you get out will be null. Because even if the model said this, the type system says, in order for this value to be valid as part of the string, it must not have gmail.com in it. So now what you're able to do is you can actually combine software, like I talked about these algorithms. So while we have base algorithms, you can add your own algorithms as a part of the system to make your system even more reliable. Because at some point, the model won't listen to you, and you can spend forever prompting, or you can write a line of code. And that having the choice of what you do. Again, I'm not saying you have to do this. I'm just saying it's good to have choices as you write code, especially in this world where everything is probabilistic. And then you can also, in this case, this is a very strong guarantee of what's happening, whereas the thing I wrote in the prompt was a weaker guarantee. It's a good suggestion, but not a guarantee. So now you can be guaranteed downstream that this email value will never have gmail.com in it. Cool. All right. So I'll pause really fast. Any questions so far? No, I hate services. Like I said, these LLM calls are really expensive. If you wouldn't write a Python microservice as a web system, this actually runs locally on your machine. It runs as a native Python package or a native TypeScript package or a native Go package. When you make a new system, all you do is, I hope I didn't leave my API key there. cd clear make dir, and I'll do it in Python, but you can do this anywhere. Make dir MLOps world, cd MLOps world, uv init, uv add bamlpy, while this runs, uv run baml cli init. Whoops. And then you just run the init. It's like create a new project. Cursor dot. And you're good to go. That's it. So, and all of this runs locally in your own machine. There's no extra network cost. There's no extra overhead, except if you're familiar with any NumPy libraries, for example. The way NumPy works is it's written in C code, but it gives you a beautiful Python interface. That's what we do. It's written in Rust, gives you a beautiful Python interface on top of it. And TypeScript gives you native Python. Name, by the way? Omi, yes. Name and then question.
Hi, I'm Sean. I have one question.
Yeah.
I noticed
Yeah, exactly.
try to make it so that the use case specific.
Yeah. Let's just see what happens. Because I dropped the null, and like what happens here? So we have a string, it must not be gmail.com. So what happens when the LM hallucinates a gmail.com? Before we run it, what would you want to happen? What would you think should happen?
Well, I would actually have a little bit different, firing from the hip here, I would have a little bit different data class. So I would actually
So we might want to bifurcate it. Yeah, so we could do that with a different class system and go bifurcate it and write a separate class with another union type along the way. But in this world where this was our type system and the LM actually made something up, what happens? Well, I'll let you run this for a second, you'll see. We actually get an exception. So instead of a retry logic or anything else, you just get an exception because this field was unable to actually process itself. So it said unable to parse field email and an assertion occurred. And in the actual exception handler, we give you all the logs about why the exception occurred. So then you can handle that in whatever way you want. You can show the user a message. You can run a retry loop. You can build some other system around it. But if you don't want the exception to occur, then you need to tell our type system that unknowable is a valid value here. And then what we can do is we can say, even though this thing doesn't match a string, another way to cast this value is to give you a null value out of it, and then you can continue on with your system. But if you want to handle this in a different way, I mean, remember, in the end, this is just code. So you can just take this and run an if statement in your Python code or your TypeScript code or somewhere else and do whatever complexity you want to add on to there, if that makes sense. Yeah, exactly. So you can do anything you want there at that point. Cool. Thank you for the question. One more question, and I'll continue on with weird context engineering stuff. Cool. Shall we continue? All right, let's do more context engineering. So now I want to talk about a technique in context engineering. How many of you use UUIDs or some identifiers or URLs as part of your prompts? Stop doing that. I'm going to give you really good intuition about why you should stop doing that. UUID generator. I'm going to generate a UUID. We'll run this one. I'm just gonna add this UUID into this prompt. Role user. I'm just gonna add this UUID here. Let's just read this prompt really fast and then see what we think. Okay. You see how many tokens this is? This is like the OpenAI tokenizer. And like I'm gonna write a different thing and just see how many tokens that is. It's really, really short. So you're just making the model's life harder when you give it a UUID as opposed to like simplified units that it can work off of, and it will just be better. Like there are tokens for all sorts of weird numbers, and even when there aren't, there are way fewer tokens than anything you do here. There are a reason when we use Git hashes, the way Git shows the Git hash is not the full Git hash. It shows you the least amount of differentiable characters you need to give you a Git hash along the way. So what we recommend is anywhere where you're using a UUID type, scratch that from your code, delete it, and put a semantically meaningful unit there. It could be a name that makes sense. It could be a slug. It could be an ID. It could be a number. It doesn't matter. So when an LM picks from one of many UUIDs, instead of picking a UUID, it's picking a number, and then you just cast it back to the UUID in your actual code. That will make your accuracy go up a lot more. It'll also allow your tokens to go down a lot more. It will basically just simplify the whole system for you in a way that is, I think, easier to understand in Grok, personally. This applies not just to UUIDs, but to all sorts of things. How many of you put URLs in your prompts? Anyone that does RAG often does, because they will link it. You should probably not do that for the same exact reason. I will show you a couple of URLs, and then we can look at them. These are good URLs. Oh, OK. Can I go to a random Wikipedia page? I think I can go to wikipedia.org/random. OK, there we go. This is it served the purpose anyway. This is a good URL. Why is this a good URL? Well, because it's semantically meaningful. So it's actually easy for the model to go generate this because it makes sense. I'm going to show you a bad URL. Don't play. Okay. This is a bad URL. Most people have bad URLs in their prompts. So what I would do in this case is I would actually be like, watch, and I would just put like a standard ID over here where it says like, engineering.mp4. And I would just do this. And YouTube probably isn't the perfect example here because the model probably has a lot of YouTube training data on like YouTube links everywhere around the world. But a lot of examples will be better like this because if you have a company that's called mywebsite.com, the system will be able to understand your prompts better. It'll understand the context of your references better, and it's not a random link. So, and why do these things matter? Like, why do UIDs matter? Why does this stuff matter? Because what we're talking about here is, what we're talking about here, there we go, is this, 5% of downtime. You got to shave off every little bit you need. And if there's easy things you can do that give you that, just do them. They're really, really simple to go do. And your system will be just that much better along the way. Cool. All right, so we talked about UIDs. We talked about URLs. I'm going to talk about one more technique along the way. Let's say what I really want to get here is I want to get companies. And we know that we're able to get companies along the way. So when I run this test case, it will turn companies out there. But what if the person put Xbox over here? How does Xbox work in this scenario? Because the company is Microsoft, but the person put Xbox. And this is an unreasonable thing to do on a resume. But if I'm building an ATS pipeline, I need named entity resolution along the way. Anyone have ideas how they would approach this problem? Has anyone solved this kind of problem before? So I'll show you how at least I think about it. What you would end up doing is you tell the model something like this. Add description, use the legal name of the company. And maybe this will work. Let's just try and see what it does. The problem with model demos is they do take time to run. And in this case, it did this, it still put Xbox. It didn't listen to me. Freaking model. OK, let's try again. Use the legal name of the company, not the product. So let's try this. Maybe this prompt will work. And like, maybe? OK, it seemed to get Microsoft that time. That's cool. It kind of did something. But it's like a guess. I don't actually know if the model will do this every single time. So let's see if we can use the type system to help us get to a better answer along the way. So let's do that. Class company. So what I'll say is I'll put the name of the company, and I'll say that this is direct from text. And then what I'll say is legal name. Use a legal name of the company over here. And then what I'll say is company type. And what I'll say here is I'll write startup or well-known entity or well-known. And I'll say there are two types of companies here. I'll actually move company type to above the legal name. And I'll show you why in a second. And I'll change my company type to be a company type. I don't need this description anymore because this is now rendered slightly differently. And now I can run this code. So now it did this. It said, cool, company type startup. It made up a legal name. We'll see what we do with that in a second. Google, well-known, Google LLC. That is the right name. Xbox, well-known, Microsoft Corporation. It actually got way better. Because what I did was, instead of describing the problem in text and plain English, I took my same problem and I described it really, really concretely with a type system. And I think a lot of people underestimate type systems because we've been prompting for so long now. But you can almost define every single problem you want from scratch with a type system. And why do you want to do that? Well, I think the reason is what I call context compression. And why is context compression important? Well, I've worked with some really good engineers in the past. One of the guys I worked with wrote the physics engine for FIFA. He's amazingly talented. And no matter how good he is though, if I throw him a bunch of bloat and then with 1 or 2 sentences about what I want to do, he probably won't get the thing I want done the way I want it to be done. If I under-describe what I want done, if you've ever run a PRD that doesn't actually describe the real thing, that's exactly what that is. It's just not expressing the thing you want. If you put too much context around what you really need, it's pointless. And here's a real application of this in this sense, where we took the description we had, and instead of trying to jam in more English, I just jammed in a type that describes what I want really succinctly. And let's just take a read at this. Almost anyone reading this can probably understand what this is trying to do and has a good grasp of what this code is attempting to do. We still have one problem in this world where we still hallucinated parts of this. So we can solve this problem though. Well, one way to solve it is we're going to say, just put a null here. Like allow the model to null it out if it wants. And we can run this again and see what happens. Give me a second. And now put the legal name null. But that's still a guess. We don't actually know. Maybe the model does know the legal name of boundary. And in that scenario, what happens? Well, we can leave this as a string, and we can do something really interesting in our code. And I think this is, again, going back to the thing I was talking about earlier, which is how can you blend heuristics and algorithms with LLMs to get really, really reliable pipelines. We're going to run extract resume, and it's going to produce us a bunch of experiences. We'll now say it's for experience in resume.experience, exp.company type. If company type equals startup, great, it's auto-completing. Just like void the company name. And now I've done this in my code. No matter what the LLM does, I will guarantee that my user will never see a company name for anything that is a startup. I could do further. I could say search my ATS for the text of the company. And I could say exp.company.name. And I could search for this. And then I could say that this thing is going to be this. Oops. I'm very bad at spelling. That was the best thing LLMs did for me. And now this can run through. And now I can solve this problem really easily. So now I can be guaranteed that no matter what happens, I can actually have always a good legal name shown to my entity. In my database in the search pipeline, if I don't get a match, I can create a record that says, here's a new name, and I don't know what the match for this is. So a human can go and search. Or a web agent can do a web search and do a bunch of function calls and for loops and if statements to search the web, crawl the web, and then go find the legal name of the company and then add this in. I can save the database ID of this generated resume somewhere and react to it when that web search has completed and found a new name to say when that changes, update my database entry. And then make that work. I can build software around these systems so that I can really trust these systems and build a magical experience for my users where they can always trust the AI pipelines I built. And instead of spending all day prompting or writing a web agent loop right in here where I have to do tool calling and run the whole loop today, I can just make that a tomorrow problem because this isn't a thing that I have to solve immediately. I can do interesting rendering techniques to make this problem go away. How many of you know how Facebook did images when they first launched Facebook.com? So I think there's a really interesting story here that talks about this. I think when Facebook first launched images, there was a thing where not a lot of people looked at images. And they had less interactivity than text post. Anyone want to venture a guess about why? Any wild guesses? Name? Steven's exactly right. You would see a blank white space, and no duh, you're not going to interact. Or they're just going to scroll to the text, which is stuff. So how did Facebook solve this problem? Well, they did something really clever. Whenever you upload an image, they made tons of downsampled variations of that image. And when you scrolled, they loaded the lowest res of the image first. And if you paused, they got higher and higher res along the way. And if you had really good network, they would just load a higher version by default instead of having to go deal with this problem. And this problem of showing stuff people correctly with right visuals and having the right actual underlying data format under the hood is what's important. In the example that I showed earlier, if you had to find the legal name of the company before you showed the user anything, think about how long that could take. Your user is going to see nothing until they finally see something. And even if it's correct, they might just leave and come back later, or maybe never come back at all. On the other hand, if I did it this way, I can show them something, and I can show a little thing next to it that says, hey, we're searching for this company. If you already know it, just tell me. If you don't know it, we'll let you know when we've found it. And how does that sort of visual help build trust with the user? Well, I think it's because if you think about like a RAG system, for example, there's many ways to build a RAG system, and many of you might have done something like this in the past. But one of the things that I find really useful in a RAG system is actually not about the fact that I can answer questions. Like, sure, we know LLMs can do that. But I think the UX about how you show the RAG data along the way is super, super important. 1 second. What is my network? I can hotspot if it's faster. And part of the UX here, for example, is the model actually generated a citation blob here, where this is a citation it found. We did additional work to go and take the original text and then search for that citation in the original text. And if it doesn't match the text that we find, we actually will flag it as a dangerous piece of citation. So now what you've done is the model cited text, but then it cited a specific part of the text and will render that appropriately. Let me run this again. And that's why at the beginning you see not found. It's because when it's an empty or a very short string, we actually refuse to match on it. But what you can do with that now is when you actually do the answer, you can actually show the relevant text around it. And not just the text the model had, but the surrounding text. But this gets really tricky, because if you're setting a Wikipedia page, Wikipedia does really dumb things sometimes, which is it has all these like squares in its text, square brackets along the way, and the model may not dump those out. They may ignore them. It may ignore punctuation. So we went a little bit further in this example. Not only do we go ahead and match the actual text along the way, we actually will do what's called an approximate match. So we'll go ahead and see if the text doesn't match exactly, we'll check and see if the text matches for everything but punctuation. And if we find that substring, then we're also good. If that doesn't work, we actually will render the text as orange along the way, so the user knows that that citation can't be trusted, very visually and very clearly. But you could take it one step further. For any text that is orange or doesn't match or your algorithm, you can take it and now you can toss it at an LLM and say, hey, does this text actually match the real text? And if it's true or false, plus another citation. And then you can show it to the user as like, this is actually trustworthy. The LLM paraphrased it for whatever reason it did. So you can build a graduated level of trust along the way. Exact match, punctuation match, or an LLM match. And we can build software to build these sort of systems really easily, assuming we have great type systems powering all of that. I'm going to take this example to what I've found to be, I think, the most interesting application of this, where you take graduated examples of software and make it even better over time. How many of you would trust if a bank provider used an LLM to do all its data processing? Probably no one. But I think there's a way you can, and I'll show you how that is. PDFs. So we work with a company. What they do is they used to spend 7 figures on processing a bunch of PDFs for bank statements along the way and understanding them. Now they spend I can't say the exact amount. They spend a lot less on doing that, and their pipeline doesn't fail. And I'll give you an intuition about why. So in this case, I have a bunch of stock transaction statements, and I'm going to ask an LLM to extract it. And at this point, you probably believe me that I can make an LLM extract this data. We've done this a few times throughout this talk already. So the LLM is taking a look at that image and extracting information. But we can take this one step further. We know something about this data that the LLM doesn't. We, as software engineers and as product people, know something about this data. We know that quantity times current price should equal the market value. There's a semantic understanding there built in. So what we can do is we can just bake that into our code base. We can say, like, given the semantics of this data, let's just see what the validation is. And we can just run the math. We can say, given the generated code, does 3500.5 times 1 equal 3500.5? In this case, it happens to. But I'm going to show you a different example where this is a little bit more nuanced. So in this case, it's a much more nuanced form along the way, and the LLM generated data. And I'm going to zoom in just so you guys see the data a little bit. So this is a stock form. And you'll notice here NVIDIA Corp has this 113.063. Anyone know what this 3 is? Someone said something? Footnote. What's your name? Divya. Yeah, it's a footnote. It's not a price. But when it generated the data, it did generate the 3. Surprisingly, it realized that, and for all subsequent data, it did not generate the 3. So it was able to build some context, but it messed up on the first one. And clearly, if I submitted this as my tax record, this would not be good because it's wrong. And you can imagine that there are many types of errors that could happen here that are magnified even further at some scale. Well, let's apply the technique that we just talked about, where we apply a validation check post the LLM generating data and see what happens. Well, when we run this check and we turn it on, we get a definitive thing that doesn't match by 27 cents. We don't know what is wrong here. We don't know if it's market value. We don't know if it's quantity. We don't know if it's current price, but we know something is wrong. So we've added a constraint in our data to help us analyze this and build trust that the model messed up. Well, what can we do with this? Because we use software to detect this. There's a couple things. One, I can have a human come in and say, hey, if any mistakes happen, have a human audit every single mistake. And now I can go fix it, and the human will probably catch this right away and be like, oh, change this from a .063 and fix it. What else can I do? Well, I know which things were wrong. It's NVIDIA Corp. So what I can do is I can take this whole row, and I can send it back to the LLM and say, hey, I found a mistake. It seems to be off by 27 cents. What's the new entry? And because the LLM is only generating NVIDIA Corp at this point, not the whole thing, it'll probably get it right. And it has context that the math was off by 3 cents. It may not be perfect, but it will be probably better the second time around. When it generates that, we can double check again if it's correct. And if it is correct, then we probably believe this a little bit more. But there's still possible mistakes that can happen. Well, we can add a second constraint, a second degree of freedom that we take away, which is we can sum up all the market values and make sure they're real and that they didn't get made up. The last thing we can do is we can actually look up every single symbol and asset name and make sure that these match up. So now not only are we doing correctness on the individual rows, we're doing correctness on the second dimension of market value. And the odds of every row being right and the odds of the sum being right mathematically, but still being wrong and not matching the paper is just really, really low. And that is exactly how Face ID works. It's not that it's like always correct. It's just the odds of the algorithm being wrong, the model being wrong, and the second model being wrong, and the other algorithm being wrong combined are just very, very, very low. And that's how you build. If anyone's ever built security systems, you don't actually build a perfectly secure system. Just the odds of it being unsecure are really, really low. And you can build these sort of constraints all across your data model. And I showed how to do it not just with like mathematical values, but also with text values. That's why I actually extract asset name and symbol, because it allows me to build a constraint that I can go and double check. I also showed how to do this with RAG pipelines that are a lot more ambiguous in terms of what kind of citations that they build, that are really free form. And I can't actually guarantee that this data is actually well cited by this sentence. But if anyone wants to posture a guess about how could we say that, hey, is this citation actually related to the sentence? Anyone want to toss a guess? What we could do is just run another LLM call to just say, hey, do I trust this sentence to match this specific sentence? And because it's not answering everything, and we know the citation is definitely real, we have another probability that it's more trustworthy. I'm not saying you should do that for your RAG application for whatever data source you have. But if you're building a thing that maybe is helping someone build, let's say, an EMR system for doctors, where you really want to make sure that if it says the patient has diabetes, they really have diabetes, or if they're allergic to latex, they really are allergic to latex, then you might want to run that extra check. And I think it's all about knowing that these tools exist, and you can combine software in this way with AI pipelines to build that level of reliability that you can get away from not just vibing with models, but really trusting them. I have a little bit more time. I'll pause. Any questions? Name? Harish, yeah. Yeah. So that, yeah. So yeah, with this financial system, we actually ran into tons of problems. And I'll talk about some concrete problems that we ran into, and we talk about them in more detail in different episodes that we have. But like, one example is like, we'll do something, sorry, let me zoom in. One example of this financial model that you might run into is you guys might have seen a lot of bank statements, but not every bank statement will actually put dollar signs in front of every single page. Sometimes they put pounds. Sometimes they have commas instead of periods because it's a European bank statement. Sometimes they only have dollar signs on the first page. Sometimes they only have dollar signs on every page but the first value of it, nowhere else. And when you do that, sometimes the model will read the dollar sign as a 5 or a 3 instead of an actual dollar sign. How do you deal with these kinds of problems? Well, first, you have to discover these problems. And if you're not putting your app in production, you just fundamentally won't discover these problems. 2, you have to find out where your error rates are happening. So you need to build a system here that can actually detect those errors. So the fact that the dollar sign was read as a 3 instead of a 5, we caught that with a constraint check, and it worked. But once you are able to model these systems and you actually have a good representative data set of what your users are doing, most problems that we have seen end up falling in like this 90-10 bucket, where the majority of problems and distribution of things that your users want to do fall into a 90%, and you have a long tail of 10. So what you do is you actually build, instead of one pipeline, you use if statements. And you basically just say, based on the type of data I have, just go to this pipeline or this pipeline or this pipeline. And you can do that if statement from different ways. You might extract, hey, what type of bank statement is this? Is this coming from a well-known provider? Is this coming from Morgan Stanley? Is this coming from Chase? And I might have really good pipelines just for those, because like Chase PDF doesn't really change very often. Morgan Stanley's PDF doesn't really change very often. And those systems might have much higher guarantees built in than, say, a tiny regional bank in the middle of Europe from a tiny city in there that no one has really heard of. And I can still handle that with lower levels of accuracy and perhaps increased latency because I make multiple L1 calls to get to the final correct answer. But my Chase Bank statements are really fast and really accurate. Does that answer your question? Cool. Yeah. Name one more time? Yeah. It didn't change? Cool.
Even after all of these, would you feel comfortable, like would you feel confident that building all of these things in?
So they actually do use this now, and it does work. It has like multiple nines of uptime on processing the data. And what's important is whenever they get something wrong, I think they have like, I can't say the exact percentage, but let's just say like it runs through every single bank statement they have, and they no longer use that other provider that was doing OCR with like humans plus. It's actually more accurate than humans with these constraints built in. And you might estimate why, because like humans are more likely to make a typo than a model in this scenario, especially with a thing that's double checking everything. But the other thing is whenever a mistake does happen, it's actually not a mistake. And there's two different kinds of mistakes for AI pipelines. There's a mistake that is undetectable and a mistake that is detectable. They only have detectable mistakes. And that is the key. And what they do is they build all sorts of systems. So like if you have less than 5 transactions and there's a mistake, they actually will make the user manually verify it. Because in less than 5 transactions, you just don't have enough confidence that that the constraints are good enough to really, really trust. If you have an anomaly on like some very, very common stocks, like it's not weird. So you can build a second level of order of like how popular are these stocks, so like how likely is it that they actually exist. And you build more and more sophisticated models to make this even more accurate downstream. Detectable errors. They just sample the data across the way, and like they generally just don't find errors as they've run through. Yeah, I think at some point like you can't know that Face ID works on every face when we built it, but you can run it across a lot of faces and then be like, okay, I guess it does work. And that's all you really can do with most probabilistic systems. Just like your system, you can't be sure that your system is completely impenetrable, but you can make sure that everything you have tried to penetrate it does not work. And then like that's what we do in security. And it's the same thing with AI pipelines. Yeah. Any other questions before I go on to some more weird stuff? Name? Line graph and crew and everything. Yeah. Well,
Because those tools are really handy. I mean,
I agree.
you know, they have their own problems, but for together, I mean, they work. Quality of life features that.
Completely agree. And like I think the nice thing is everything here is just a function. And all those tools accept native Python functions. So you can just plug it in wherever you want. So like because it's a function, just add a node that does this thing, I guess, and then you just plug it in. So nothing, it shouldn't be extra work. Omri, right? Omi, sorry, yes.
Along the line of tools that are popular, like his own LLM call.
We have to make the LLM calls, but we have a system that's like a modular API, so you can actually just make the LLM calls yourself and take advantage of the parser. So it's designed to be like really, really composable. Oh my god, why did it do this? Zoomed in views are very hard. And then you can just make a web request yourself and fire it off using whatever parameters you want. And then you can just run the parser or the streaming parser yourself for every method, and then you get the type safety out of it. So you should be able to run it in any single system, even if you don't own the HTTP request. Any other questions? You guys want to see more weird stuff? All right, let's show more weird stuff. But before I show the weird stuff, I just want to quickly summarize what I wanted to talk about, which is the real premise here is I think if we go from a world of way less F strings, way less prompting, just more engineering and add more type safety, we end up with a system that is really reliable and really maintainable. All the tips and tricks I thought about context engineering you can do anywhere else. It's just harder. You can build an infinitely scrolling website without React. It's just harder. And everything is just code. Like under the hood, any machine, any system that tells you you're doing something magic is lying. It's just code. And you can always read the code to figure out exactly what's happening at all times, and that should always be true. Anytime a system has made it harder for you to read the code, it's made it harder for any LLM to contribute to your code base. It's made it harder for your humans to contribute to this code base. And I think the premise is add readability that gives you maintainability and reliability. Everything I showed you is completely open source. It's air gap, so it has no internet dependency. It's completely polyglot, so it works in every model, every language of your choice. It should work on every architecture of your choice that you want to run it on. I think we have people running on like embedded machines, which is really weird. It runs on any model of your choice. Because you shouldn't be limited on where you use AI, just based on the technology that you use. That said, we did make a stupid programming language, and I do understand that. So what we have is a really, really good Discord response time if you have any problems. This is our response time for last year and a lot of this year. I can't say it's perfect. It's not AI powered yet, but it is humans. It's our team out there because we did make a stupid programming language. The least we can do is really get out of your way and let you actually write code and not have you be stuck on it. We have thousands of companies that use this in production, all the way from government agencies to big companies, all the way down to tiny startups and teams of high schoolers. So it should really be readable for anyone that is trying to get out there and try and use it. But don't trust any of those people. That's why I don't put any of the logos of people that use us on there, because you should make your own judgment call on whether or not this is a thing that actually helps you ship faster. You shouldn't be biased in any way. Because code is, I think, something that's very personal. And someone that loves Python is going to love Python, and someone that loves TypeScript is going to love TypeScript. And someone that loves Go is going to love Go. But hopefully, BAML is a thing that makes all of your agentic stuff be a thing that you love writing and not a thing you despise long term. And the thing that your team can contribute to over time. One more slide, and then I'll show the last parts of my stuff, which is if you found this interesting and you found that this was, you might want some links about it, you can sign up here. I'll send you the Notion doc that I was talking through, so you can read through it. It's like 15 pages with a bunch of other techniques. If you want to search for me, you can search BAML on LinkedIn, and you should find me. If you search for BAML on the web, BAML should be rank 1, Bank of America Merrill Lynch, rank 2, us. So you should be able to find us. And then what does BAML stand for? I showed this at the very beginning, which is it's basically a made-up language. Because that's what it is. In fact, that's what all things are, but we are especially that. And then I'll take 1 or 2 last questions, and I'll show the weird, cool stuff that we're doing next. Name and then question. Yeah. Yeah.
Dove a little bit in.
Yeah. Thank you. Name and then. Yeah. How do you do that? Yeah, I'll show that in a second. That was one of the cool things I was going to show after this. And you can plug into any other system you want as well. But I think we have a more interesting take on a system that you might want for observability afterwards. Any other questions? Cool. Let's talk about the weird stuff now. So what we talked about is we talked about type safety a lot today. I think we talked about how type safety makes the whole system easier, makes it more elegant, makes it possible to build really good pipelines. And what we did today is we added type safety. TypeScript brought type safety to your front end and back end in the same way. And now you could use the same types across the way. What we did is we showed how to add type safety to your front end, to your back end, and through AI pipelines by using BAML. But we just asked a really, really good question about how do you deal with observability? Because if you're running an AI pipeline, and even the gentleman over here was asking a question about at some point you're going to have production data that doesn't match the system, and you have to build data models around the world. That means you probably have some data storage layer that's going to capture all the things you're running, and you'll go do this. And you've probably seen a lot of observability systems that do this. But what if we had observability on your type system? An observability system that actually tied to your type system. And I'll show you what that ends up looking like if you were able to do that. Because like I said, I really, really love type safety. People that don't love type safety haven't written really, really big code bases that don't have type safety in them. If you've ever worked in a large Python monolith code base that was written in Python 2, you know the pain. So what we said is let's just add type safety purely to our database layer as well. So what we do is we take the type system that you wrote, and then we build a complete type safe database view on top of it. So now your inputs and outputs are purely type safe. Like we said, the LLM stuff is still useful. I guess it's interesting, but it's not the part that I really want to have. I know under the hood I'm making some web requests over here, and I know I have some source code that powers it, but what I really want to know is the input to this function was a thing that had this shape, and the output was a thing that had some other shape. And I'll show you what that ends up looking like if you do this. If you actually have this system, then you can turn this into a test case. And you can go really quickly from an observable system to a test case. And you can only do this if you actually know the syntax of the code that is being written. So you can help bridge what we call the boundary of two systems, which is the boundary between what is actually happening in your code today, or what is actually happening in your pipeline today. And that is best answered by a really simple question of what does your source code say is happening? So you read the source code. And there's a bottom boundary, which is what has happened in your system so far. And what that does is it's able to say, what is the observations that I have made about my system under the hood? And can I go query that out? So this is kind of our solution to this. But of course, you can build your own and go do everything. BAML is completely open source. All the network calls are visible. And you can also capture all the data with like OpenTelemetry or something else if you prefer. But you just don't get type safety. It just matters if you care about type safety. How this works is Slack. Studio. What this does under the hood is if you have Slack has a really weird bug where it won't show you see all. I think they're trying to save bandwidth by not rendering all these images. But let's render this. What this means is if I had a function that was calling extract resume, and my resume type had a type where email, phone, and company were strings, but then company changed to be a data model, the database actually segments that for you automatically. So when you query it, you get 2 separate database calls, not 1. Why do you want that? Because if you're building AI pipelines, data sanitization is the most important thing that you have. Let's say you built a classifier of some kind. Let's say you built a classifier that's like let's say we're building a shopping agent that's going to chatbot intent. That's going to determine some intent along the way. And you're going to say something like return order, cancel order, sure, some of these. And you have these. And let's say the user for that input picked return order. But later, your engineering team or your PM or someone else added these 2 new categories, and the user still picked return order. That is a fundamentally different data entry. Picking return order when you have 3 categories versus picking return order when you have 5 categories is a totally different data set. If you're going to build ML pipelines, you need to have access to that purity of data set, and BAML does that automatically for you. If you write the code, it's automatically versioned on a schema level, and you get really, really clean systems out of it so that when your code changes, your database changes for free with no engineering effort. So that's what we think is really important for observability. You want type safety on the observability layer so that it's tied to the code base as close as possible. So that when your PM says something is broken, what they say is, hey, extract resume isn't getting company.name right. And the language has become a lot faster. So even if an AI agent wants to go fix the code, Claude Code can just literally grep for extract resume and company.name and go fix it automatically instead of saying something is broken. It's a lot easier for it to do. You can say, hey, my phone number field actually seems to be working really well. Let's drop it down a model and use a really cheap model to generate phone numbers and an expensive model to generate companies. And you can go measure the metrics of that and see what that did along the way. So that's what we think is important for observability. I think I have 1 minute left, so I'll take a couple last questions, and then I will go on my own way. Yes?
Sean, so for the observability thing, actually, in my mind, SQL that you're managing, right? You always put the integration.
Yeah.
So you always have version history.
Yeah. But
Abstract version of that thought process.
yeah. And
Or would you say?
kind of. The only difference is we don't actually do the data migrations yet. We just store the observation. So you can view it as a write-only view where you can write into it and append only, and you query it. So, but you could imagine we could build migration and say all the old data should migrate to the new schema because we know the type system of both.
The point is where you say,
Yes.
we need to think about this.
Yes.
Right? And the strong typing gives you the ability to do that.
No, I hope it's useful. We just took we said if you took type systems to the nth degree, what would happen? And that's kind of what we thought when we made BAML. One last question, or are we good to go? Yeah.
This is more curious than what are the future.
You want to see more? I can say a little bit later and show you guys more, even weirder things you guys want. Okay, let's do it. So I'll show you what's coming up. I can't show you everything that's coming up because some of it's still in development, and I hate people showing me stuff that doesn't actually work yet, personally. So I'll only show you stuff that is either working or very, very close to working. So step 1, and this was a really, really wild bet that we made, which is we actually made BAML tiering complete. So you can actually write your whole app in BAML if you want. It's faster than Python. It's faster than TypeScript from our runtime. It's because if you took a lot of work is being done to write stuff in Rust, and they write a lot of tools in Rust. We basically just wrote Python in Rust, and it's a lot faster as it turns out, and it works. So you should have this. And why did we do this? It's not like a random thing. As you write more BAML code, it actually became really. We talked about the UUID thing. people really want to containerize that within BAML, where they can just say, if I pass in a UID, change it to an integer and change it back. It's very closely related to the prompt, but now you have to go bridge between Python and TypeScript, so you don't have to do that anymore. Another benefit is because BAML generates code in every single language, users have been using this for a thing that we didn't expect, which is they actually write all their data models in BAML, and then they just generate all the types, even the things that are not LLM related, just to generate types that bridge across every language in a really nice way. It's like protobuf, but like ergonomic, which is what I found to be the worst problem with protobuf. Because as much as serialization, all that stuff, all the performance matters are there, I really just want it to be nice to type and feel good. And that's what we do. So we try and make it as native to every language as possible. But then the next step came up of like, I want these types, but I want a method that is shared between all these languages. Well, it turns out by making BAML Turing complete, we not only can expose types, but also methods, because we already do that. So now you have methods that are available across every language that is all shared. So if you're building any sort of shared SDK, that's a common thing that you get for free. And again, it all runs locally. It all runs natively in the same Rust runtime. So if you test it in Python, it will work in TypeScript, and you don't have to think about it, assuming the versions are aligned. Version mismatches can do interesting things. So this should be coming in really soon, as in it works today soon, but we don't advertise it. So for the recording people that are watching it, hopefully by the time you see this, it's actually live, but you should expect this in like January, like under GA. But the other thing I think is like we talked about LangGraph. Honestly, visualizations are really freaking cool. I think visualizing agentic systems is actually really important, especially if we want non-engineers to work on them. And in a world where like AI is generating half the code, and like I talked about like AI generating 10,000 lines of code per second, that will happen. And I have no doubt that someone will go do that. But in that world, like Git review, all these other systems break completely. Like you just can't, all existing software processes don't work. And I don't want to live in a world where N8N is the code I write. So we said, what if you could do something further, where you have something that has a capability ceiling of code, but the usability of Excel or N8N, where like anyone can feel like an engineer and feel really close. So we took that to the nth degree as well, because why not? And that's something that we've been spending a lot of time thinking about, which is what does it look like when you have all this data? I might actually have the, not this one. OK, it's on Slack. I'll pull it down. This one. I will download this. And if this downloads, this will run. And I excuse the super low quality here. This was when we did video stuff, but then didn't realize that we weren't recording in HD. But when you look at this, you'll notice that there's some hashtags over here at the very top. If you really, really squint, I apologize for in the back. And this isn't to say that this is the answer, but it's a way, and these hashtags aren't comments. They're a way to inject visualization into the system. And why do we do that? Well, if you have hashtags that describe the semantic definition of code in some meaningful way, where you're leaving a comment that has some what I'd call a structured comment, well, then you can build a visualization of it really easily as well. And when you build a visualization of it, you can do something else, because the visualization is backed by code. You can click on it, and they'll take you to the right line of code that it maps to. So you can choose how complex you go into it. And this graph, unlike most things that render code, are not randomly complex. It's actually semantically complex, because you are choosing as an engineer how much complexity you show on the visualization layer, as opposed to just showing every if statement, every for loop, and every function call. Because that's not how I think about code. I don't think about it every line of the way. There's like chunks of code that do semantically meaningful things. When I visualize it, that's what I want to see. In a world where AI generates code, you could imagine a world where the first thing it generates is all the structured comments of what the code should be doing. And you can actually see that as it's generating it. Then you could take it one step further and say that I'm going to highlight this box and go to a Claude Code or whatever coding agent is popular at that time to go update that section of code. And the compiler can prevent it from updating any other section of code. The way we look at Git diffs might be, I'll look at the structural diff of my code, and then I'll zoom in onto Git diffs onto specific areas that I really care about. So I can scan and understand code really, really quickly. But because it's all backed by a thing that I think is really powerful, which is the file system, There's no abstractions, there's no cloud, there's none of that stuff. You want something that's really simple, has command click, has all the tool chains we're used to, but at the same time gives you the ability to do the things that N8N and other things do. So this is some of the other stuff that we're thinking about. Question?
Question on this one. This I see comment and line of code.
Yeah.
But it seems like you've already identified a group.
Yeah.
Model takes care of that. So naturally,
Exactly. And you could imagine that we run a linter, or you run a linter that says, for every structured comment, read the code snippet below it and make sure it makes sense. And now you have a linting check on top of that. That leverages AI, it doesn't fight it. But I think when I think about tooling, and when we think about tooling, we try really, really hard not to invent new syntax in BAML. Inventing syntax is evil. You should not do it whenever possible. But there is a caveat in which we do, and sometimes we choose to deviate away from TypeScript. So BAML looks almost like TypeScript, except when it doesn't. And there's very, very few scenarios in which we choose to do that. But like this gives you an idea of kind of how we approach the world, which is make it readable at all costs. Because every programming language to this date has been optimized for what I would say some balance between reading it and writing it. And that's kind of the trade-off that we've made. Python is extremely readable at some cost of making writing it tolerable. That's why Python doesn't have types, because writing types is actually intolerable for a lot of people. And that's OK. That's why JavaScript doesn't have types, because writing types is really, really annoying without really, really good tooling. It took TypeScript a long time to come out after JavaScript, because type systems are notoriously hard to build. Anyone that used GCC knows how bad error checkers are. And there's nothing you could do in GCC to redo error checking except rebuild it from scratch by building Clang. Sometimes you just can't rebuild certain things. But in the world where writing code has become basically free, in some sense, because LLMs will write the code for us, we suddenly don't have to make that trade-off. We can say, we can make writing code a little bit more painful, not too much more painful, because it still will be, we don't want it to be like intolerable, at the benefit of readability. So what does that look like in a really tangible sense? One is structured comments. We can add them in, because we can introduce some new syntax as long as it's cohesive. But another thing you can do is like constructors. So we all know how we declare constructors in TypeScript. You write types like that, or some of us hopefully do, and like the other of us can look up how TypeScript works. And you write TypeScript like this. And in order to know what type nested is, you have to hover over it, and it'll tell you what type nested is. And it'll work. It's really freaking good at that. But this is just more readable, without having to do a second lookup. It's a little bit more annoying to write, but it's a lot more readable. So if an LLM is generating code and you just see this line of code, you can go do this. Not only is it more readable, you can give better errors. You can give better messages to the user. And both a human and a coding agent will have a better time grokking what's happening. So we made a distinction in BAML compared to TypeScript, where while we allow anonymous types, our formatter or our linter will give you a warning that says you should label the type. And that's the type of system that we want to go build. Optimize for readability at all costs. Name.
Follow-up question on this. I think the traditional reason why these types are not duplicating the schema into the payload.
Yes.
And that means that if the schema ever is backward compatible but upgraded,
Yeah.
You end up with a problem.
So you just need to make sure that that works syntactically. Well, we can do that because we own the compiler. So like if you add a field that's optional, it should just work. Right? You shouldn't have to declare every optional field. So we should be able to infer values.
But a rename of the...
Well, rename's easy because an LLM can grep for CLS in every place it's used and go rename it. And it's actually way easier for an LLM to do that than to do it here. Because if you rename this field to A, how do you find every variant of A that you need to go change? It's really, really, really hard. On the other hand, we didn't get rid of the LSP. You can still click right-click rename, and that'll still work too. So like we still do all the basic LSP stuff. We don't make it harder for humans to write. We just make it easier for models to write and consume. Any other questions? Cool. We have some other weird stuff, but I'll pause here because I've been talking for a bit. But if you guys are, like I said, are interested in getting in touch, this is probably the easiest way. And then I love talking about BAML, so let me know anytime. I'm always happy to hop on, talk, either on Discord or on in person while I'm around at the conference, or online over some Zoom call or something else. Thank you guys for listening to me talk. I hope this is fun.